Okay, I just wanted to go over real quick about this hard start kit. So when we're talking about saving the unit itself, as far as amp draw and everything, we had basically a 66 amps that was starting our system. And if we multiply that times volts, in this case, it's going to be 240. So bear with me here while I go back and actually put in 240. And then we're going to multiply that by a power factor of about 0.8. This is more or less the power factor on, the loss of, real work versus the work that's actually being done, because this motor actually moves it, and there's a phasing that happens. It's kind of complicated, but that phasing is not going to be it's not going to be a static amount of power that's being used like an electric heat strip would be something that's static. So if we take 66 and we multiply it by 240, that's 15,840. And if we multiply that by 0.8, that gives us a total of 12,672 watts. That's the amount of energy that this particular compressor is using on startup. So if we do this exact same thing, if we lower it to 36 amps, because remember we dropped it from 66 to about 30, we still have the same voltage and we still have the same power factor, then this is going to tell us how many watts that we actually saved this person, or basically what they're using right now. So 36 times 240 equals 8,640. Multiply that by 0.8. That's going to be our power factor. This particular compressor is now only using 6,912 watts on startup. So the difference between those is pretty substantial. So we are actually saving this client, every time it starts, 5,760 watts of electricity by putting in a hard start kit. Hope that helps.